once again. So we will conclude now on our last topic for the performance of the line for the ABCD constants. So we need to determine now what are the ABCD constant of a long line. So we already discussed short line, medium lines, nominal pi, nominal t. Well, in these long lines, I did not draw the single line or the per pace diagram simply because we already described this one from our last few slides. But please take note, if you have a long line, it has the complete parameters wherein your ZL is R plus JXL while your Y is G plus JB. See, XL and BC here are your this is your inductance, while BC is your susceptance, while R and G is in terms of resistance and conductance respectively. So it has a complete parameter R, L, and C. Okay, based from our analytical solution or using rigorous method, we already established these two important equations. But what I've done in this part is I use the format of what we have on the two-port network so that it will be in line with the corresponding units. So as we have mentioned, you have A VRN, B IR, then C VRN, D IR. And based from this one, we can now establish the ABCD constants based from the two-port network matrix. Please take note that ZZ here, or the surge characteristic impedance, is square root of ZL over Y, which we discussed from the long line how we deal with a radicand, and we also discuss how we will deal with the sine and cosine hyperbolic functions respectively. Thus here we have the following constants. A is equal to this cosine hyperbolic of square root of ZL times Y, which is very evident. C is equal to sine hyperbolic square root of ZLY all over ZZ, which is also the same here. As you can see, this one is definitely your C constant, D constant, A constant, and last but not the least is ZZ times sine hyperbolic ZLY, which is definitely, this is your B. Actually, we can still simplify this one. If you can still recall, your alpha, so you have your propagation constant, right? So this is based from long line. So we can actually change that ZL Y to alpha. So we need to check if our ABC constant is correct. So incidentally, it's also the same with the principle that in two-port networks, A times D minus B times C must be equal to unity. And thus, if we do so, cosine hyperbolic square root of ZL times Y, or alpha squared, minus the sine square root of ZLY over ZZ times ZZ sine hyperbolic of ZL times Y. So definitely ZZ will cancel out, giving you sine squared and cosine squared. And the identity is simply equal to 1. Okay, so we already described the long line and other types of line in terms of its corresponding ABCD constant. So we will discuss on the next slide the regulation of the line if you have these constants on medium and long lines. Please stay tuned. Hello once again. So let us have the conclusion of our performance of the line in terms of short, medium, and long, and we are on the ABCD constant. So as you can see, we have plenty of parts for the fundamentals first, because it's very important that you know the principle first before we attack some problems. So this is the last part wherein we need to get the regulation of a line, or the so-called the same thing, voltage regulation. So now we will make use of of this formula for medium and long line, but I will discuss further when we go to the short line. What's the difference? But regulation of a line is simply defined, as a change of voltage if you have the receiving end voltage or the receiving end is pulled off or turned off, or it means that there's no load, right? So that is the so-called regulation. So the lower the regulation, higher efficiency. It means a good power system or a good transmission line efficiency. So let us have a recall on the ABCD constant. So we have this first row. Okay, so this is the row for VSN, which is AVRN plus BIR. So it means that if there's no load, there's no current at the receiving end. So we can have the BIR as 0 here, and it will be leave behind VSN AVRN. But this VRN here is definitely your open circuit voltage. I could say VRO. Now we can now get VRO simply as VSN all over whatever the A constant of the line, This is the A constant of a certain transmission line, if that is short, medium, or long. By the way, we considered only this one in terms of magnitude only because when you compute for the VR, just the numerical value in terms of percent. So we need only the magnitude. So let's go to the definition in terms of equation of a voltage regulation. That's the difference between the full load voltage in terms of the open circuit voltage, VRO minus VR over VR, times 100%. Now, since we are considering here a medium or long line, so VRO is VSN all over A. Your A here will depend on type of line. Blue marker. Depend on type of the line. This A bar or the magnitude minus VRN all over VRN. And then you multiply by 100%. So you will have a percentage value. Now, how about short line? So that's why this is the main formula here, because it will depend the A will depend on the type of the line. So if you have a short line, you consider your A simply equal to 1, right? So if you have a medium line or a long line, the A's will be dependent on the equation, right? Or on what we have discussed on the last few slides. So thus, this is the formula of a regulation in line depends on the A constant or the general form. Okay, since we already discussed all of the principles and fundamentals, so let's solve some problems on our next video. Stay tuned. Maraming pong salamat.